Expand 1 plus 2x to the power 12 in ascending powers of x up to and including the term in x cubed, simplifying each coefficient. So we'll start with 12c0, 1 to the power 12, 2x to the power 0. That's our first term. Our second term, 12c1, 1 to the power 11, 2x to the power 1. Our third term, 12c2, 1 to the power 10, 2x to the power 2. And then our fourth term, 12c3, 1 to the power 9, 2x cubed. Simplifying each of those, 12c0 is 1, 1 to the power 12 is 1, 2x to the power 0 is 1. 12c1 is 12, 1 to the power 11 is 1, 2x to the power 1 is 2x. 12c2 is 66, 1 to the power 10 is 1, 2x all squared is 4x squared. 12c3 is 220, 1 to the power 9, 2x cubed is 8x cubed. Simplifying each of those terms, 1 times 1 times 1 is 1, 12 times 1 times 2x is 24x, 66 times 1 times 4 is 264, and the 220 times 1 times 8 is 1760 x cubed. So that's my answer to part A. Part B. By substituting a suitable value for x, which must be stated, into your answer to part A, calculate an approximate value for 1.02 to the power 12. So comparing my expansion to what I'm being asked to find here, I can see they both have a power 12. So on the inside, this 1 plus 2x, let's make that equal to the 1.02. Take the 1 away from both sides, and I find that 2x is equal to 0.02. Divide both sides by 2, and so x is equal to 0.01. So when I substitute that into my expansion, it's going to give me an approximation for 1.02 to the power 12. So 1 plus 24 times 0.01 plus 264 times 0.01 squared plus 1760 times 0.01 cubed. Which gives me 1.26816. So that's my answer to part B. Part C. Using your calculator, writing down all the digits on your display to find a more exact value of 1.02 to the power 12. So if I substitute that into my calculator, just 1.02 to the power 12, typing that in, that gives me the answer 1.268241795. So that is a more exact answer than my previous estimate. Part D. Calculate 3 significant figures the percentage error of the approximation found in part B. So, percentage error is found by doing the actual value, take away the estimate, divided by the actual, times 100. So if I take my answer from part C, the 1.268241795, and take away the 1.26816 answer that I found in part B, divide by the actual, multiply by 100, and I find the percentage error is 0.00645% to 3 significant figures. So you can see a tiny percentage error, absolutely tiny, insignificant, I suggest. So our answer in part B was actually really, really accurate.